last question we solved, we used 300 rats instead of 500 rats. And the question asked us to use 500 rats. Because this is WT plus theta. Okay, this is W stands for wavelength, and which is 500. So now we're going to solve using 500 watt. So if your answer is not with, I ask you guys to inbox me your answer on the comment below. So if your answer is not the same as mine, we should go back and recalculate it so that you won't have mix-ups in your exams and probably test. Okay, let's look at this. We have
See the presence underneath. See the presence.
Place voltage here, 3 milliamps, 4 milliamps, and 1 millifarad. So what do we do first? We bring out all these parameters. For L1, we have it to be 4 milliamps. Now not wasting our time. What I will do is that I will just solve this by finding for the reactance, inductance in the primary side, which is L1, and that is going to be SL will give us W L1, and W, we know W to be what? To be 500 times, this is going to be 4 times what? Milli, that is times 10 raised to minus 3. So whatever you have, that is what you got for 500 for reactance of the inductance for the primary side. So we have 500 times 4 times 10 raised to minus 3. So 2 ohms. Because this is a reactance, measure in reactance, so it should be in ohms. The next one is L2, secondary side. We have it to be what? 3 milliamps. And our reactance for the primary inductance, secondary inductance, is going to be W L2. That's also 500 times 3 times 10 raised to minus 3. And that should give us okay 1.5 ohm. Good. So we are done with that. What next do we look for? We look for our capacitance. So reactance, capacitance for the primary side, we have it to be what? 1 over WC1 is going to give us 1 over 500 times 1 millifarad, that is 1 times 10 raised to minus 3. Okay? Punch the calculator, what do you have? That is 2. Our answer there is going to be 2 ohms. Okay, since having this, the next thing we do after we have gotten our reactance, inductance primary side, reactance, inductance for secondary side, and now we are having our reactance, capacitance. The next thing we should do is to find for our impedance for S. Impedance for S is going to be minus J times our capacitance, which is going to be SC1. And this is minus J already. And what do we have for SC1? 2 ohms. So here is going to be 2. Okay. And minus J times this gives us as equal as minus J2 ohms. Okay. With that, we are going to look for our total impedance. After getting this, look for total impedance. Total impedance here is going to be SL2 plus into bracket ZS parallel 2 plus SL1. Ask me why. This is ZS for here. And look at this. If I should draw in parallel and series resistance, this is a parallel or series resistance, this is a parallel resistance. So when solving it, you solve it parallel to each other. Let's assume this place is having us, let's assume this is ohms, this is ohms, this is 2 ohms, this is 3 ohms. And we solve this. It's same thing as me saying 2 parallel 3. That is 2 times 3 over 2 plus 3. This one will give me 6 over 5. Then 6 over 5, okay? The same thing we're going to do here. this side is going to be parallel to 2 plus our reactance inductance we have for here. So parallel to each other. So now how do we solve this? SL2 we don't know. So I will skip this and let's not solve this first. SL2 we know it, but I don't want to solve this together with this. So let me bring this out first. So I have ZS parallel to 2 plus SL1. Okay. Now ZS here is going to be what? Minus J2. Okay. Parallel to 2 plus SL1. SL1 is 2. Okay. J2. So we just be 2 again. J2. Okay. Parallel to each other. This will give us minus J2 times into bracket 2 plus J2 over minus 2J or J2 plus into bracket 2 plus J2. Okay. Now let's look at this. First of all, I can rewrite this. If I should write this, I should have something like this bottom side. I should have something like minus J2 plus times 2 will give us plus 2 plus times plus J2 give us plus J2. And here I can always write it to be minus J2 times 2 plus J2. Okay. I know most of you guys will be wondering, okay, will I say, okay, let's keep that and continue. Before I proceed with that, let us look at some things. For us to have a better understanding, this is minus J2. What does minus J2 means in ordinary number? It means 0, 2. What about 2 plus J2? Ordinary number, it means 2, 2. Why? This place is not having any ordinary number here, so I realize that it's 0. 0 is nothing. And we have 2. Here is 2. And this is 2 here, also 2. 2 here, also 2. Okay? So now, I'll bring out my calculator and punch this out now. This is what I wrote now for this. So now, by pressing pause, I press 0 for here, 2. If you don't understand this yet, please put it out in the comment section below. I will chat you up privately. Then we have this. We have 2. And this gave us 2. Okay. RCL and tan. This gave us 90 degree. Okay. Times into bracket. And this is 2. 4. 2, 2, close the bracket, equals to 2.8, 2.8, okay. RCL and tan, we have 45 degree over, then this is minus J2 plus J2, okay. So what will be our answer like that? Since here is having minus J2, here is having 2, then J2 will remove J2, then we're left only 2 here. Then here will be giving us only 2 here, okay? Now this, will you say 2 times 2.8? No. I hope you understand what I did here. This minus J2 cancel this minus J2, this plus J2 here. Okay? Will you say here that 2 times 2.8? No. Whether you add them together. 2 plus 2.8. That will give us what? That will give us 4.8. And this is 90 plus 45. Not 90 times 45. 90 plus 45. That will give us 135 degree over 2. You can go further and say 2 plus J0 if you wish, or just leave it as 2. Okay? While doing this, what do we notice with this? We have here, we'll change this part to something like this, exactly something like this. So let me clean this, and this is going to be equal to, remember this 2 will now be equal to 2, 0. So I'll give down my pole, 2, 0. I have 2. In RCL and tan, I have 0. So I have 2, 0 degree. So 4.8 divided by 2. 4.8 divided by 2 gives us 2.4. And this take it up will still be 135 degree. Okay. Having this down, remember we said our total of impedance here is SL2 plus the solving of this, and which we have solved it to give us this. So what is the SL2 now? Our SL2 in what we solve is giving us 1.5. So 1.5. Our J there is 1.5. Okay. Plus 2.4, 135 degree. Now we will change this now to something like J. How do we change it? Now this time we are going to make use of RCL and pole, shift and pole. Shift and pole to give us something like REC. Okay, we have 1.69. Mean this, arrange it in the proper way. It's going to be minus 1.7 first before you add this. 1.5 plus 1.7. 7 plus 5, that will give us 12. That will be 3.2 plus 3.2. Okay. Now with that, what do we do next? The next thing we're going to do is that we're going to convert this back again to something like this, exactly like this. Okay? Then convert this back, we get our 4 minus 1.7, comma 3.2, shift, no, what am I doing? Close the bracket. We have here to be 3.6. Okay, RCL and tan, we have this to be 117 or 118 degree rather. 18 degree. Okay. And the question asks us to look for current. Now this is the main reason why we are looking for current. The main reason why we are looking for current is because of this impedance. We have voltage already. Remember in your secondary school, we have the I is equals to V over R. Now, the R we're going to make use of is what they call impedance, which is also measured in what? Ohms. Now, we're going to say I, which we're looking for it, is equals to V over Z, our total impedance rather. Okay. B here is equal to 400. I will not write 400 cos 500t, but no. What I'm going to do is that 400 angle 45 degree divided by what I have here is 3.6 angle 118 degree. Okay, so equals to what? 400 divided by 3.6. I have 111.1 angle. Okay, so we're going to divide this together. So I have this 111.1 or 111 rather, and we have this is 118. This is having a positive sign, but this positive sign is not needed. Just like me saying 1. 1 is having a plus 1, just like plus 1. It's same as 1. So this 118, when it's going this way, we're going to take this up. It's going to become a negative sign, giving us something like 45 minus 118. Minus 118. So 45 minus 118 will give us what? Will give us minus 73. 73 degree. So this is not what we are going to stop. We're going to convert this now to something like this. Then we have our current to be equals to, we have 111, cos into bracket 500 t. Now this is going to be minus 73 degree as our final answer. So if you have these two as your answer, superb, you're good. But if you don't have it, you can always take correction and move with us. I bet you before the end of this month, before you engage in more of the tutorials, you should be able to be proud of circuit theory. If not, you can unsubscribe. But if you are liking it, loving it, and you're getting the best from it, please ensure to comment and share this video to those who you care for. Thank you and God bless you. Solving past question. Like and subscribe to our channel.